Okay, we're going to start with exponential functions. Today's objective is to graph exponential functions and to identify their property. Your homework are the problems on page 4 on the back of this worksheet. So I want everyone to write down the definition of an exponential function is a function whose base a, where a is greater than 0, a is not 1, and x could be all real numbers. And go ahead and write down these examples of exponential functions and things that are not exponential functions. And after you write those down, think about what you notice about things that are or are not exponential functions. So hopefully what you noticed is that the exponential functions have a constant, a number as a base, and a variable as an exponent. And the non-exponential functions have constants as exponents and variables as bases. The first two are actually polynomial functions, and then over here, because it's a negative exponent, we have a rational function. So we are going to explore some of the characteristics of exponential functions. Everybody grab your graphing calculator, go to y equals for number 1 on this page, and type in 2 to the x in y1 and 4 to the x in y2. Then go ahead to your table of values and we're going to fill in the numbers. So we've got, you should see 0.25, well that's 1/4. 0.5, you should see 1, 2, 4, and 8. Which makes sense because an exponential function is a multiplication pattern of 2, and you can see clearly here the numbers are doubling. Not surprisingly, here the numbers are multiplying by 4. We're starting with 0.0625. Then we've got 1/4. Then we've got 1, 4, 16, 64. So if we were to graph these, I'll do the first one in blue. We've got 0, 1, and then we've got 1, 2, and then here we've got our exponential growth function. And if we will do the other one in red, we've got -1, 1/4, but then again 0, 1. And this is also an exponential growth function, but it grows faster. All right, so let's look at these two exponential decay functions. If we go and type these into y1 and y2, let's write down their tables and graph them. So for 1/2 raised to the x, we've got 8, 4, 2, 1, 1/2, and then 0.25, which is 1/4. And then for 1/4 to the power of x, we have 64, 16, 4, 1, 1/4, and I happen to know that this is 1/16 because the pattern is dividing by 4. So if we graph this, I'm going to do again, this one I'll do in red. Move it, buddy. This one I'll do in blue. So -3 and 8, that's too high. 4, 2, 1. Oh, I missed. Oh, pretend it goes through the points. And then the red, we've got okay. So keeping these on your paper, let's answer the questions below. Both graphs on the left have a domain of all real numbers. Any x value we can put in there, but they only have a range of y is greater than 0. We could also write these as -infinity to infinity, and then 0 to infinity. It has a y-intercept of 0, 1. They are both increasing on the interval of all real numbers. They both have an asymptote of y equals 0, and they are continuous. Now looking at the decay functions, they also have a domain of all real numbers, or negative infinity to infinity. They also both have a range of y is greater than or equal to 0, y is greater than 0, not equal to. They also have a y-intercept of 0, 1. The difference is these are decreasing on all real numbers. They both have an asymptote of y equals 0, and they are both continuous. So, now what I would like you to do is turn the page and work on the back. Okay. You can do these by hand. And then I want you to check the features with your calculator. And pause the video because I'm going to reveal the answers.